Hey everyone, Chang here and welcome to my channel. Today I'm going to go over a topic that's super underrepresented. It's introduced in classroom for maybe a week and it's just completely ignored. Let's change that. That's right, today we're going to cover the greatest common factor or greatest common divisor. It goes by two names but it's basically the same topic. By the end of this video you're going to know what the greatest common factors are, how to find them, and why they're even important in the first place. Let's start off with factors or divisors. Once again, they're basically the same thing, just different names. Well, for a number to be a factor of another number, it means that for the other number, you can break it down into a multiplication. Now, those multiplication, the numbers that are multiplying each other to become that other number, those are factors. What do I mean by that? Well, for example, let's just say 20. We know that 5 is a factor of 20 because 20 can be broken down into, well, 5 times 4. That also means that 4 is a factor of 20. Now, if you have an example like 11, which is a prime number, there's really nothing else you can break it down into. In this case, the factors would be just 1 and 11. Now, the greatest common factor or greatest common divisor is basically a comparison of a group of numbers. What you're doing with that group is you're looking at all their multiples and you're picking one that they all share, but rather than just picking any multiples, you're actually picking the largest shared multiple. So, for example, if we look at 12 and 28, well, factors of 12 are 1, 2, 3, 4, 6, and 12. Factors of 28, 1, 2, 4, 7, 14, and 28. Well, guess what? They share the number 1, 2, and 4. Now, 1, 2, and 4 are common multiples of 12 and 28. But when you're looking for the greatest common factor, or greatest common divisor, however you want to call it, you're looking for the largest one that they share. Well, in this case, it's actually 4. So, our greatest common factor of 12 and 28 is 4. If you look at this example, the greatest common factor or the greatest common divisor of 6 and 18, well, first and foremost, the factors of 6 is 1, 2, 3, and 6. The factors of 18 is 1, 2, 3, 6, 9, and 18. Well, when we compare all the different factors, we can see that the greatest common factor or the greatest common divisor in this case is 6. I mean, that's cool and all, but every time we need to find the greatest common factor or the greatest common divisor, we have to list out all the factors and then compare them and then find the biggest one. That seems like a pretty big waste of time. And plus, why is it useful anyways? Other than the handful of time where basically you're asked specifically to find the greatest common divisor or greatest common factor, standardized tests, or that one jerk who's going to be coming up to you thinking they're all smart and be like, what is the greatest common factor of these two numbers? Or what is the greatest common factor of these three numbers? Right? There are other usage for that. It's not just those handful of times. Now, two that I can actually think of right off the bat is, well, the first one is to help you factor. Name, factor. The other one is actually to help you test divisibility. And I'm going to go into more details about that in a bit. As we start using more and more math in our daily occurrence or in our studies, we start encountering situations where we're basically required to factor numbers out of different expressions. Now, greatest common factor helps guarantee that when you factor things out, you factor it out to the max. There's really nothing else you can factor out. What do I mean by that? Well, let's look at this expression. 12x plus 28y. From our previous example, we know that the greatest common factor between 12 and 28 is 4. Well, in this case, if we have to factor out some number between x and y, the greatest number between x and y, we know that we're going to factor out 4. And when we factor out 4, what's left over in this case is going to be the 3x plus 7y. And we know that we cannot factor out anything else. We are done in that situation. Well, let's look at another expression, 6x plus 18y. Once again, from our previous example, we know that the greatest common factor is 6. So if we have to, we can factor out 6 from both the x and y. In this case, it would be 6 parentheses x plus 3y. And we know that we cannot factor anything else because what we just factored is the greatest common factor. The test of divisibility, or the divisibility test, is basically a complement, a support to divisibility rules. Now, what do I mean by that? Remember this, the divisibility rules are a set of rules that lets you very quickly determine when you divide one number by another number, is there going to be a remainder or not? Well, guess what? To memorize all the different divisibility rules is not practical or a good use of time in that matter. So what we need is another way. We need a way to systematically test if one number is divisible by another number when we don't remember the divisibility rules. Well, that's how this works. The divisibility test is based on the greatest common factor. In order to test if one number can be divisible by another number, you're going to find their greatest common factor. If the greatest common factor happens to be one of those numbers, that tells you, that guarantees that one number is divisible by another number. Now, what do I mean by that? Here's an example. Here we have 219. Is it divisible by 73? Well, we can actually test that. We can divide it if we really want to. But if I tell you for a fact that the greatest common factor between 219 and 73 is 73, then we know for sure that 219 is divisible by 73. Now let's look at another example. Let's say we have 4,500. Is it divisible by 144? We're not sure. We can test. Or if I give you the greatest common factor between 4,500 and 144 is 12, then it's not one of those numbers. It guarantees us that 4,500 is not divisible by 144. And we can test that with any number. Alright, well that's all talk, no action. You just went on and on about what a good thing the greatest common factor is, but you still haven't told us anything really important. We haven't found a way to figure out what the greatest common factor between numbers are. Well, let's talk about that now. Okay, in order to actually find the greatest common factor or greatest common divisor of a group of number, what you're going to need to do first is look at every single individual numbers in that group and break it down into its prime factors. I have a video on prime factorization that I'm going to put in the description down below for you to reference. So after you break every single number into its prime factors, you're going to compare all the factors. You're only going to look at the ones that each and every one of those numbers in that group share. So if one of them have 5 and the other one doesn't, then ignore that, right? You're only going to look at each and every one that they share. And out of all of them, you're going to pick the one with the lowest exponent. And you're going to, I guess, put it aside. You're going to put it out. And then whatever you have, all the ones that you've selected, what you're going to do next is you're going to multiply them. The end result of that multiplication is your greatest common factor. So let's go over examples so you guys can clearly see the different steps. So for example, we have this problem. As you can see, don't get scared by the notation. It literally stands for greatest common factor or greatest common divisor. So you might see it in two forms, GCF, greatest common factor, or GCD, greatest common divisor. So you're looking for the greatest common factor between 240 and 36. Well, here's what we do. Based on the step-by-step component, first and foremost, we have to look at these two numbers and we're going to break it down into its prime factors. Well, 240 is equal to 24 times 10, and you can break it down further into 6 times 4 times 5 times 2. Break it down further and eventually we get this. 2 to the 4th power times 3 to the 1st power times 5 to the 1st power. Well, for 36, we're going to break it down. That's equal to 3 times 12, and 3 times 12 can be broken down into 3 times 4, which in the end will just give us 2 squared times 3 squared. Now, we can see all this. Look at this. 5 to the 1st power is only in one of the numbers, not the other, so we can completely ignore that. Now, we have the 2's and 3's. Well, in this case, they share 2's and they share 3's, and the 2's, the lowest exponents in terms of the 2's is 2 squared, so we're going to take that out. And the lowest exponent in terms of the 3 is actually 3 to the 1st power, so we're going to take that out. So here we have 2 squared and 3. Now we're going to multiply them. 2 squared is equal to 4, and we have 3. So 4 times 3 is 12. So in this case, the greatest common factor between 240 and 36 is 12. Well, every now and then you're going to encounter examples or problems that's similar to this. So, for example, you're looking for the greatest common factor of 63 and 100. Well, we're going to go through the steps. We're going to break each and every one of them into their prime factors. 63 equals 9 times 7, which is basically 3 squared times 7 to the 1st power. 100 is basically 10 times 10, which is 2 squared times 5 squared. Now notice this. They don't share any factors in common at all. So what do we do in this case? Well, actually, in this case, the greatest common factor between 63 and 100 is just 1 and nothing else. Now, on the side note, this is an example of what they call relative primes. It means that the two numbers share actually no multiples, no factors together other than 1. That's why their greatest common factor is 1. Now, let's go through one more example. This one looks kind of scary, but remember this. Again, it's just notation. The GCF stands for greatest common factor, nothing more. So rather than just finding the greatest common factor between two numbers, this time you're just trying to find the greatest common factor between 3 numbers. You're trying to find the greatest common factor between 24, 36, and 56. Well, let's break them all down. 24, when we break it down into its prime factors, is what? 4 times 6, which is basically 2 to the third power times 3. 36 is what? 4 times 9, which is basically 2 squared times 3 squared. Well, 56, if we break it down, is just 8 times 7, which is 2 to the third power times 7. Great. Now we're going to compare, once again, all of its individual prime factors. Well, for the 2's, we can see that out of all of them, 2 to the second power is the smallest number. So we're going to take that out. Does all of them share 3? No. Does all of them share 7? No. So that's it, just 2 to the second power. So that means, in this case, the greatest common factor for 24, 36, and 56 is just 4. Well, that was pretty simple, pretty straightforward, not too bad, not too complicated, right? Show me your skills.
1.
Just a keynote, I will have the answers in the description for those of you guys who are curious and want to check your answers.
3.
Well, thank you for sticking with me until the end of this video. Let's summarize what we went over. Factors and divisors are basically two words that mean the same thing. Now, for a number to be a factor of another number, what it means is that for the other number, when you break it down into its multiplication, a possibility is that number. That's what makes it a factor. Now, common factors usually talking about a group of numbers, sometimes 2, sometimes more than 2. What you're basically doing is that for every single number in that group, you're looking at all their factors. Whichever factors they all share, that's the common factor. So when we're talking about the greatest common factor, we're looking at all the possible factors that each and every one of them share, and we're choosing the greatest one of them all. To actually find the greatest common factor, what you're going to do is for each and every single number in that group, you're breaking it all down into its prime factors. You're comparing the prime factors and seeing which one they all share. Now, for those that they all share, you're choosing the prime factor with the smallest exponent. After you're done choosing, you're going to multiply them all together. The end result of that multiplication is your greatest common factor. Now, in cases where they don't share any prime factor, basically you know this. Their relative primes and their greatest common factor is 1. Greatest common factor, or greatest common divisor, basically, whichever one you prefer to call it, is like the least common multiple in the sense that it's tools. They're basically all tools. They're there to help you with stuff like checking divisibilities, factoring, or just working with fractions. So even though there's not much emphasis on it, it's actually very important that you have these tools so whenever you need them, they're there for you. Now lastly, please like, comment, and subscribe out of respect for this wonderful little tool. Yes, it's not emphasized and it is shown for maybe a week and then tossed away, which it shouldn't be. But I mean, if it's not for this little guy, we wouldn't be able to say, so this number is divisible by